Hello, can you hear me?
Yes, ma'am. Yes.
Okay.
Good evening, ma'am, and good evening to all the uh, teachers, students who have joined. For today's Mastery Symposium. To tell you about this this particular sessions that we have been conducting from last 3.5 years,
Very good.
where we bring diverse people, people from different walks of life to inspire and give insights to teachers, parents, as well as students.
Mhm.
Uh, to just a window for students and parents to see the world uh, over the shoulders of our school. We are very lucky and privileged to have you, ma'am, today.
Thank you.
Before I hand over the session to you, let me introduce to all the audience today about our guest speaker today. Uh, she uh, she is a scholar who has obtained her PhD from New York University, and is a scientist where her mathematical application research work has been applied in all fields, not just in engineering, not just in economics, even in biological sciences. That's quite interesting, quite insightful to know how mathematics is going to influence science, sciences, biological sciences especially. Uh, he is a professor, of course. She taught in many prestigious universities across USA, even in India. Tata Institute of Fundamental Research. Also, I will start now.
Oh,
Speaking all all actually she's the founder of aims to empower in India, especially rural kids, and like poor households. I still remember where all were hurrying to go outside. She was very busy trying to help poor people doing all the work. Very sad man. We managed to hardly do our best. We have section. We have both feelings.
your voice keeps cutting out. Can you hear me?
I mean, we are getting some sort of background noise. And
I can't hear you. Your voice keeps cutting out.
is it okay, ma'am? Now?
Yeah, this is better. This is better.
Yeah.
Yeah.
So this session we have both students as well as teachers. Hand over the session to you, ma'am.
Okay. So before I get started, I want to understand what is the landscape at your end. I see that there are 48 people on Zoom. Does every student have their own device, on laptop or phone or something?
Exactly. Yeah.
Okay, very good. So you're not physically in the same room.
No, ma'am. No, we're not.
All right. So this talk I will give ideally would be in person because then you can see, body language, excitement, and you can also read students' faces. But I can't do that. However, I would be very interested in entertaining questions. So if you guys can use the hands up device available, I would appreciate it. Whenever you want to ask me a question, then I might ask you questions too, and some of them are open ended, which don't really have an answer right away. I would also like to request Bharat to moderate in the sense that, while I'm talking, I may miss a hands up sign. Then feel free to interrupt me and tell me that somebody has a question.
Sure.
Or will that be okay?
Yeah, yeah. Could you please
Okay.
turn on your video so that viewers know?
Okay. Thank you very much for having me. It's a real pleasure and an honor. I don't know if Bharat has told you how we met. Actually, first we met only once in Bangalore physically, but he was doing this walk from Kanyakumari to Kashmir, which he may have told you about, and I was very impressed by that. So I got in touch with him, and since then we've stayed in touch. Okay, I think it's wonderful that he's at Vasavi School. Is that the correct pronunciation?
Yes, ma'am. Okay.
Okay, yeah, and hopefully inspiring all of you, all the kids. Okay. So the title of my talk, I'm going to switch to a share screen mode, and which means that I'll be able to see your hands less perhaps, but let me try. So do I need permission to do? Okay, I have permission. Yeah. Okay. All right, can everybody see that? Yes? Okay. All right. So thank you again, all of you. The title of this presentation is The Curious Kid. So does everybody understand what curious means? And Bharat, you can answer for everyone. It will be fine. Do you think everyone understands what curious means?
Yeah.
Okay. Just in case somebody doesn't, in case some of the students don't, it's somebody who wants to know. In Sanskrit, it's jigyasu or jigyasa, if you know Hindi or Sanskrit. Okay. So who's the curious kid? Well, it's each one of you. It's each one of us. And the more curious you are, it turns out, the better you are in life. Okay. So what I'm going to talk about is various things that you can explore on your own. Okay. So I'll start with something very basic, numbers. Okay. You learned numbers starting in kindergarten. You learn to write 1, 2, 3, 4, etc. Okay. But as you climbed up in classes, you learned about negative numbers. You learned about, hopefully you know about the real line, but I'm just going to assume you don't know any of this. So this line I have drawn represents the number line. Okay, you could also call it the real line. I'm going to call it the number line. And what I put is I put 0 in the middle and all the numbers to the right. I'm only using integers, which means no fractions, no decimals. And I can go on to the right, 1, 2, 3, 4. I can do 5, 6, I can keep on. And to the left, -1, -2, -3, 4, etc., all the negative numbers. So my question to you, first question to you is, how far to the right can I go? Can anyone tell me the largest number they know that I can put on this line? You can put it in chat if you want. I think I can see the chat. Actually, yes, I can see the chat. I would like someone. Oh, okay. So you already know the concept of infinity. What does infinity mean? What does infinity mean? It means something that you can't reach if you keep going. And if we go to the left, how far to the left can you write? If I go to the negative numbers, how far can you write? Anyone?
Yeah.
I have one response. Okay, negative infinity. All right. So what is negative infinity? What is negative infinity? Well, it's still infinity, except it's in the opposite direction from what you call positive infinity. We are more comfortable with positive numbers, right? You give me any positive number, I can give you a number larger than that. The same way you give me any negative number, I can give you a number smaller than that. So negative infinity is infinity in the negative direction, therefore it is much smaller than positive infinity. Okay. But I want to be able to compare numbers. So there's something called the natural numbers. In case you don't know what that is, I've started writing them. 1, 2, 3, 4, 5, 6, and you can keep going on till infinity. Actually, you never reach infinity, but you can keep writing. So these are called the natural numbers. Okay. If I include 0 and the negative numbers, then that's called the integers. And mathematicians denote natural numbers with a capital N, bold N, and integers with a capital Z. Okay. So both, would you agree, both have infinite number of numbers? And the question is, are they the same size? I mean, they're infinite, right? So whether I start from 1 or whether I start, even if I start from negative 10 and go to the right, I can do minus 10, minus 9, minus 8, minus 7, so on and so forth, right? So how do these two numbers compare in size, in the sense, these sets of numbers? So which one is bigger? Or are they bigger, or are they the same? Any idea? Any guesses?
Can you repeat that last question, ma'am?
Okay. I want to compare the size of integers. So integers is a set of numbers. It's a collection of numbers, right? I've described to you what the integer is. Let me close this chat, I'm sorry. So I've described to you what the integers is. It's all the negative numbers, the negative integers. So no fractions, no decimals, and all the positive integers, all the natural numbers, and 0. Okay. Whereas the natural numbers starts at 1, does not include negative integers, so it goes 1, 2, 3, 4, 5, 6, etc., all the way to infinity. Whereas integers goes from minus infinity to positive infinity. So my question is, I want to understand what is the size of these two sets? How do they compare with each other? N has infinitely many numbers in it, and Z also has infinitely many numbers in it. So is one of them bigger than the other, or can we say they're the same size? Any guesses? The answer is actually quite simple. So if you look at the integers, you notice the natural numbers is a part of the integers, right? All you do is you start from 1, 2, 3, 4, 5, 6. So I could have written the integers as all the negative numbers, 0, comma, and this capital N to represent the integers. So it stands to reason that the natural numbers are contained in the set of integers. So why are we discussing this? People think math is calculations, calculus, some algebra, geometry. Somebody has answered, and let me just see if I can, natural number. No, it's not the same. Okay, so one person said it's not the same, and that's correct. In fact, natural numbers are contained in the integers, so both are infinite. Both are infinitely large. In the sense, they all have infinitely many numbers in them, but the natural numbers are contained in a larger number of infinite numbers. We can never reach this infinite numbers though, but we do know the relative size. In mathematics, we are always very interested in comparisons. We are always very interested in relative sizes. We're always very interested in estimates. Why? Because we don't know everything. We know very few things actually. But then the few things we know, if we understand them, then the things that we don't know, we can compare that to the things we know and try and understand them. I hope that makes sense. Okay. Just like we did just now. I compared the natural numbers with the integers and concluded that even though n has infinitely many numbers in it, it's still smaller than z, the integers. Okay. Now, if I throw in fractions into the integers, does anybody know what I get? I get another set of numbers with more things in it. Does anybody know what that set is? Okay, I have the answer here. Those are called rational numbers, and it's denoted by script Q. So what is it? It's all the integers, so it's z plus all the fractions, which means those fractions can be written as decimals. I don't know why I cannot see the chat so easily, so I have to keep opening this box. And somebody answered. Okay, you guys are smart bunch here. They know everything. So how many? So my question: you have integers, which is, and all the fractions. So which one is larger? Obviously, by the same logic as before, integers are contained in the natural numbers, and natural numbers are contained in the integers, correct? So what's not contained in the rational numbers? Any idea? Is there anything we have not included? I want to see what people know, so I don't repeat unnecessarily. Irrational. This is Sharanya. Is that a student or is it a teacher?
Yes, ma'am, it's a student.
Student, excellent. So give me an example. Okay, very good. These kids are smart. So non-terminating, non-recurring decimal. Very good. So non-recurring decimal and non-recurring decimal is actually a rational number, right? But non-terminating decimal is an irrational number. Okay. So there's another question here, another comment here, irrational. Very good. Okay, so I have a question for you. How many even numbers are there? Easy answer. I know it's easy for you guys. Obviously infinite, right? So even numbers can be negative, it can also be positive. Okay. So where do these lie? Does everybody know what a Venn diagram is? Have you seen what a Venn diagram is? Yes, yes, yes. So I have two yeses. This doesn't mean everybody knows, all the students know. Okay. Everyone's not replying, so a couple of people, the same people are replying. I'm going to go ahead and explain what a Venn diagram is just to be safe. Okay. So but before I do that, there's a comment I want to make. So if you can see this, I put a brackets here and I've written countable numbers. So natural numbers, integers, rational numbers, these are all countable. What does it mean? They're countably infinite. Okay. What does it mean to be countably infinite? It means you can put them in one-to-one correspondence with integers. Integers, obviously, you can match up the numbers with itself. But even natural numbers, you can put one-to-one correspondence with the integers. Also, the rational numbers, fractions, also you can put into one-to-one correspondence with the integers. But this is where it becomes very interesting. When I say one-to-one correspondence, I write down the rational numbers, I start writing them down. Of course, they're infinite. But I can align them up with the integers. Okay. Still, there are more rational numbers than the integers. So it seems like, in the end, we should find a mismatch. In the sense that we should reach some rational number for which we cannot find an integer to match it up with. But we never actually reach that point. And the beautiful thing is, the reason is because they're both infinite. So we can keep going and get exhausted, but we'll never reach the end of the set. Just check okay. Pictorial representation. All right, I'm giving you one. That's on my next slide. Okay. So this is a Venn diagram. When you have a bunch of things, a set, and you want to understand the relationship to each other, then this is how you write a diagram. Okay. So what we've discussed so far is just the yellow set. The rational numbers, we said, is larger than integers, and integers are larger than natural numbers. So that's why the natural numbers, which is the red set, is contained within the integers, which is the brownish set, which is then contained in the rational numbers. Okay. Then we can go to real numbers. So what are real numbers? They are rational numbers plus irrational numbers. Is there anything else in the real numbers? Does anybody know? Because if I look at this diagram, it looks like there is something besides irrational and rational. It turns out there is. It's a small set. They're not, it's hard to find them, but these are called transcendental numbers. Okay, there's one answer. I must look at it. It's the same person who's set of rational, irrational, real numbers. You're absolutely right. But there's also transcendental numbers. Okay. Some transcendental numbers are irrational numbers. And then beyond real numbers, there's complex numbers, which has imaginary, which are called imaginary numbers. And the reason we have those is because we wanted to be able to take square root of negative numbers. When you're a child, you just look at square root of positive numbers, right? Square root of 4, square root of 2, you know how to calculate them, either using a calculator or some other method. But how do you take the square root of minus 4? How do you take the square root of minus 2? So to accommodate that, to answer those questions, somebody extended the numbers to complex numbers. Okay, that's all I'll say about it for now. I like it that you guys are interacting. Set of rational numbers and set of irrational numbers. Okay, same answer. All right. Now, I asked you, there was a question I had, how many integers are there? And I answered the question myself. There are infinitely many. But on this diagram, as an exercise, I want you to add the set of even numbers to this Venn diagram. And you don't have to show it to me now, okay? You can show it to Bharat later, or you can, at the end, if there's time, you can submit your answers, okay? So do that as an exercise when you go home. In other words, draw a diagram on this, which represents the set of even numbers. Where will that fall? All right. So we talked about infinity. Well, you know what Albert Einstein had to say? Everybody heard about Albert Einstein? He's a famous scientist, a physicist, actually. He said only two things are infinite: universe and human stupidity. And he says, I'm not sure that the universe is infinite. What does that mean? It means only human stupidity is infinite. Yeah. So I don't know if you agree about this or not. You can discuss it with your classmates. My battery is losing power for some reason. Just give me a second. All right. All right, so let's move on. I want to discuss what is a scientist. All right. So before you pick up a stone and look at it closely, what's a scientist? What does a scientist do? Any idea? You want to share your responses? I'd like to hear. And I'm going to assume people don't have an idea. But you've heard about scientists. You've heard of scientists' names. Albert Einstein is one. There's so many others. I see a couple of responses and I want to check them out. Discovery, or tell some new things to the world, person who discovers something. Okay, Rohan, Shashank. I'm sorry guys, I'm having trouble here with my battery. Just give me a second. All right? Yeah, I agree with you. It's people who discover. So here's, pick up a stone and look at it closely. All right? If you look at it closely, you know, different scientists will do different things. If you look at a mathematician, he'll wonder, how can I calculate the volume of this? Okay. But if you ask a chemist, then the chemist will say, what is a stone made of? What material is it made of? So the motivations depend upon the person who's an interest. It doesn't mean you have to have a PhD to be a scientist. Any one of you can become a scientist almost overnight. A physicist will ask, why is this so heavy? And maybe something else. Okay. A biologist will tell you why this stone has no life. Maybe some other things too. Maybe it'll tell you it has bacteria on its surface after examining it. Okay. And a geologist, geologists are people who study rocks and things like that, will try to find out how old is a stone. So there are many different types of scientists. But the fundamental thing about a scientist is being curious. Okay. Not just for a scientist. In life, you need to stay curious. So staying curious is very important. Okay. If you want to be successful in life, you have to stay curious. What does it mean to be curious? It means you have to ask lots of questions. Okay. Lots and lots of questions. And it doesn't matter if the person you ask gets angry. It doesn't matter if the person you ask says, don't you know this? It doesn't matter. Very important that you keep asking questions of yourself, from your teachers, from your parents, from your friends, and just questions about the universe. Because that is what is the secret to be successful in a very happy kind of a way. So I'm going to come to another, actually before I do the next slide, I'm going to do an experiment on the board, and I hope you can see it. There's a board behind me. I'm going to go back there and draw. So hang on, and this means I'm going to take off my earpiece and I'm going to talk loudly. Okay. Can you see me? What I'm doing is I'm drawing a circle, and I'm using a container to draw the circle.
We are not able to see you, ma'am.
This is a rough, I don't know if you guys can see, but I've drawn two circles, just approximately. And I'm going to measure, physically I'm going to measure the circumference and the diameter of each circle.
Camera is still off.
Could you hear me?
Your voice is okay now, but your camera is still off.
Oh, okay. The share screen is still on. Sorry about that. So I'm going to stop share for a second, and I'm going to show you a board on which I've drawn circles, two circles. Can you see this board?
No, ma'am. Your video is off.
My video is not off. Video is not off. Okay, I think this experiment is not going to work out the way I expected it to. So here, let me ask you to do it. I'm going to ask you to do this at home. Draw two circles, just using a container, like a round container, or you can do it using a compass. But I don't want you to measure, calculate the circumference of the circle. I want you to measure it using a string. So you take a string, wrap it around the perimeter of the circle, and then like that, and then you measure this against a ruler, okay? And you do the same thing with the diameter of the circle. Write these things down. Do the same thing with the second circle. Both circles should be of a different size. So it's unfortunate you couldn't see this. You write those two things down, and we can come back to it if you have time right now. Well, you probably don't have a compass and handy, but you can do this afterwards, and I'd be happy to discuss again. Okay. Then, once you found the perimeter of the circle, which is the circumference, and the diameter, what you do is you divide the perimeter by the diameter for circle 1 and do the same thing for circle 2. And you can do this for 3, 4, 5 circles. You can do this for 3 or 4 or 5 circles. And tell me what you get. You can submit your answers to Bharat and he can forward them to me. Okay, let me give you a hint. You should get almost the same thing, approximately. There'll be some errors based on your measurement, but otherwise you should get almost the same answer for every perimeter divided by the diameter. Okay? Let me switch back to the presentation. Does anybody have any questions on this so far? Okay, I'm going to switch over to the presentation. Just give me a second. All right. So, the questions I'm asking you are just very standard questions that people have asked through life. You can ask all kinds of questions of yourself, anything that interests you, and get to the bottom of it, get to the bottom of the answer. So here is something we're going to do. I want to know what are the things that float and what do they sink when I put them in water. So pick a banana and get some raisins. If you don't have raisins, you can get chana or any kind of beans or something like that and put it in a container full of water. So I'm going to actually do that just now and show it to you. But before I do that, I want you to guess which one is going to sink and which one is going to float. And tell me your answer in the chat. Raisins will sink, okay, banana sinks, beans float, okay, different answers. All right, good guesses, but opposite guesses, right? So I'm going to do this right now in front of you. Hopefully you can see. I have a container of water. Unfortunately, it's not transparent, but I'm going to see. Can you guys see it? Can everyone see the container of water?
No, ma'am. Unfortunately, your cam is still off.
But it's on here.
Yeah. Wait now. Just now we have it.
Can you see now?
Yes. Yes.
All right. So here is a container of water. I wish it was transparent, but I couldn't find a transparent container. And what I have here with me is a banana. Okay. I'm going to put it in. I don't know if you guys can see. Can you see?
Yeah.
What's happening to the banana? I see several responses. Okay, it's floating, right? Now, I didn't have raisins, so what I did was, I took some chana dal. Can you see that in my hand? And I put it in here. They sank to the bottom, tiny little things, right? So some of you guessed that the banana sinks and the beans or the chana dal floats, but that was counterintuitive, right? So sometimes the intuition doesn't work. Okay, I want you to try this with other objects at home. So the banana floated and the chana dal sank, even though the chana dal was so tiny. Okay. You can try this with other objects at home. I'm going to do the same experiment with something else. Do you know what plasticine is? Do you guys know what plasticine is? You know, it's Play-Doh. Same thing as Play-Doh. It's like plastic kind of stuff that children play with and make things. You can actually get it very cheap. But if you don't have that, you can take some atta. So here, I made some atta from which I make roti. Okay. And what I'm going to do is that I'm going to throw it in the water. Into the same bowl of water. And I'm going to share screen, stop sharing screen so you can see it. In the same bowl of water, I'm going to throw this ball of atta. It sank to the bottom, right? Now what I'm going to do, as I'm talking to you, I'm going to take this atta. I'm going to turn it into a shape like this, you know, like a diya type of thing. Okay? And I'm going to put it on the water. Can you see? It's floating. I don't know if you guys can see. So what's going on here? So what's going on here? Could everybody see that? Have I lost you guys?
No, ma'am, we can hear you.
Okay. Could everybody see that the atta, the ball of atta sank, but when I made it into a little bowl, it floated? But it's the same material. So what's the difference?
There is one answer by Suputraj.
Okay.
Because of air, it is floating.
Because of air. All right. What do you mean by that? What do you mean by air it is floating? What changed? I want you to tell me what changed. There's air also around the ball of atta. So maybe you can try and explain a little better.
Suputraj, now you are able to unmute yourself. Please elaborate your answer.
Yeah, you can unmute yourself.
The shape of the atta is entering the air to it.
Okay. it's partly right, but I want you to tell me precisely what has changed.
We have two more answers, ma'am. Let me read them, ma'am. Advit, go ahead.
Yeah, you can speak up.
Yeah, Advit Raj.
Shape is changed and low pressure. Low pressure. Where is the question of pressure? It's the same pressure. I think it's the same pressure. Same material, right? In the case of the banana and the dal, you may have thought, oh, okay, I mean, yeah, this one is, it's a bit of a surprise. But with the atta, it's the same material. I just changed the shape and it floated. So what happened when I changed the shape of the material? See, I didn't enclose any air. So somebody said air. Because it's still open. It was open, you know. It wasn't like closed material with air pumped inside it.
One answer by Rajkumar sir. He says it's volume, change in volume.
Change in volume, excellent. That is exactly what happened. So the things that sink versus the things that float, the difference is that the things that sink, they're more dense. What I mean by dense is that there's more material in a small amount of space. In the banana, even though it's a big object, there's less of the banana in each piece, each cubic unit of volume compared to the little grain of chana dal. It's more dense. Okay? So at home, I want you to do this with a lot of different objects and that you're curious about. You may have some idea about which object is more dense. Okay? Now, if you studied physics, you know that you can actually calculate the density if you know the mass and the volume. And I'll share that with you just now. So with the atta, when it was packed tight like this into a ball, it was more dense than when I turned it into a flat, like a katori, like a container, small container. The volume changed. The same material, I spread it out and the volume increased. Can you think of an example of some very heavy material which floats because of the way it is shaped? Something from real life? Ships. What are ships made of? Sharanya? I have to go back in the chat. They are made of iron or wood, whatever, heavy, something heavy, right? The iron, you take a piece of iron, a nail, put it in water, it sinks. But this huge ship floats because the volume it encloses is huge compared to the amount of material there is. Okay? So the density of the ship is actually less than the density of the water. If the density of a material is going to be less than density of water, it will float. If the density is bigger than that of water, it's going to sink. Right? So what floats, what sinks, why? These are questions we're asking. Okay? It seems like it's a very simple concept based on a simple formula. But when you actually think about it, it's very, very complex idea. And was discovered by somebody called Archimedes. You may have read about him. So does the shape matter? Well, the shape matters because the shape alters the volume. Does the volume matter? Clearly it does. Okay. And we know this formula from physics, that density is mass divided by volume. So what is mass? Does anybody know what mass is? Does everybody know what volume is? I assume you know. Volume is the space occupied by the object. Okay. But what is mass? Weight is equal to mass. I was hoping somebody would give me that answer. That's actually not correct. So mass, when gravity acts on mass, that is when you have weight. Okay. Now, for practical purposes, when you're doing experiments, people will weigh and use that for mass. That's a different matter. But mass is just the material without gravity. And the reason I'm saying it's not the same as weight, because this formula should work anywhere, not just on Earth. If you take a particular thing, object, a ball of iron, it has a certain density here. It has the same density in the moon. Otherwise, this would not make sense. I mean, we can't have different densities in different places. However, because there's no gravity on the moon, the iron ball just sort of floats around in the air. It doesn't really sink down. Okay? So mass is the amount of material. Okay? And density is mass divided by volume. The density of water is 1 kilogram per liter, or you can say 1 gram per centimeter cube, per millimeter cube, sorry. So you have to keep the units in mind when you calculate density. Okay. If you have the density, if you have the volume, you can calculate the mass. So the question arises as to how do we find out mass? Well, if you have density and volume, you can calculate mass. Otherwise, you have to find some way of determining what it weighs, and then from that, canceling out the effect of gravity. So here's a warning: mass is not the same as weight. Don't make that mistake. Right? So write down, do this experiment in with multiple different things in groups, and you can guess beforehand what you think is going to sink and what is going to swim, and you'll be surprised how many times you may not get it right. Okay. As a last, time is up. I know, sorry, I'm going a little over. I want you to write down on a piece of paper. This is a private thing for your exercise for yourself. Write down all the reasons why you don't ask questions. Okay? We don't ask questions. We're shy about asking questions. We're afraid to ask questions. Sometimes people ridicule us. Sometimes it's the teacher who ridicules you. Sometimes you're told you're stupid if you ask a question. Sometimes you're told, I told you so, that's why. Whatever it is, on a piece of paper, make a list of reasons why you don't ask questions, and then share it with somebody, either your friend, somebody you trust. If you trust your teacher, share it with them. The teacher may be surprised and may be able to change their behavior. You can share it with your parents. You can need not share it with anybody. But be very good exercise to sit and write down why you don't ask questions, and then see how you can change it. Okay. All right. With that, I'll end. And if anybody has questions, I'd be happy to take it. And you can unmute. You need not use the chat. All right.
Anyone could raise your hand. I can unmute you so that you can ask questions.
You can ask questions about other things, not necessarily just what I talked about.
Yeah, Nikhil, go ahead.
Okay, I'm all ears.
Ma'am, how can I speed up the maths?
What do you mean by that?
Means I want to write speedily or calculate the speed of maths, and
You want to be fast in calculations.
Yeah.
Okay, first of all, why do you want to be fast? Can I ask you?
Because I will slow. I can't complete other works. When I start maths, it will finish. It will take more time, and I can't complete other works.
Okay, let me ask you, do you like maths?
Yeah.
You like maths. Okay. The only answer to be able to do calculations fast is to do them a lot. So you have to practice. Okay. If it's addition that you're slow at, the more you do, numbers become your friends after a while. And try to notice patterns. You may have seen people like Shakuntala Devi, you may have heard of her. I don't know if you've seen her. And others who's like magicians, you give them large strings of numbers and they calculate very quickly. Well, you know what it is. Some of them, of course, have something very special going on in the head. But any of you can learn to calculate very fast large numbers, multiplication, addition. But you have to do it with, when you are doing maths, you must be totally focused. You must not be thinking of other things. And that's true for any subject, actually. But if you do maths mechanically, you'll always be slow. But if you try to do it with understanding, so notice patterns. Notice patterns. For example, I'll give a very simple example. Okay. So let's say 21 plus 23.
Yes, sir.
Hello? I don't know what happened. I'm sorry I lost you guys.
Yeah, ma'am. No, not an issue.
Yeah. So I was answering a question by the student. How do you speed up calculations? The only answer is practice, and find little tricks. So the example I was giving is 21 plus 23. It's also very important to catch yourself when you go wrong. Okay. So 21 plus 23, I mean, like this, you should know it's 44. If it takes you time to write it down, put a plus sign, etc., it means you're not really familiar with the numbers. Okay. Some easy tricks are you find the numbers that's closest to 23. So like 20 plus 20 is 40, and 3 plus 1 is 4, 44. But this happens very quickly with practice. You start to find shortcuts. So I hope I've answered his question.
Is there anyone who would like to ask? We have Advait.
Raj, yes.
Yeah,
Go ahead.
Good morning, ma'am.
Good morning.
Actually, I want to ask that why we use constant in different types. Like if we use pi value as 22/7, one answer comes. If we use as 3.14, another answer comes. So how can we solve that problem?
It's a very good question. So the one problem that I wanted to discuss, which I didn't finish because I couldn't organize a view on the board, was the perimeter divided by diameter. Okay, so if you're going to go home back and try this for different circles, right? But let me go ahead and give you what you should get as your answer. You should get an answer which is the same as pi. And what is pi? Is it 22 by 7? 22 by 7, what kind of number is that? Is that a rational number? Is it an integer?
No, ma'am, it's an irrational.
But then it can't be 22 over 7 because irrational numbers cannot be represented as fractions. So what's going on here? So 22 over 7 is an approximation that school children are taught. But once you enter college, you have to throw that out. So you better get used to it. 22 over 7 is not pi. Neither is 3.14. Pi is irrational. And there's whole bunches of people who use computers to try and find out the next digit. So one of the definitions of irrational numbers is that if you have a decimal, it's never ending, right? It doesn't repeat. So it's not 3.333. That's a rational number, right? But if it's 3.1479621, and there is always a different number. There's no pattern. There's no repetition. And it never stops. You can keep on to infinitely many decimal places. That's an irrational number, and that's pi. But for convenience, you end up using 3.14 or 22 over 7. It's actually not neither. That's an approximation. Does that make sense?
Yes, ma'am. Thank you.
Okay.
Still, can still take one last question.
Okay.
Nihal, are you there? Nihal.
Sharanya has a question. Sharanya had her hand up.
Sharanya, okay.
Okay, go ahead, Sharanya.
Ma'am, how do you think that maths would help us in the future?
Okay. It helps you in the present also. It helps you in everyday life. Okay. What are your interests, Sharanya? What are the things that interest you? Can you hear me?
Trigonometry, ma'am.
Trigonometry interests you. Okay, that's one branch of mathematics. Okay, mathematics is it's called the queen of all sciences, and the reason is it's like the backbone of everything you do. Even if you don't do science, it's the backbone of just about everything that human beings do. How cities are laid out, how they're planned, how do you pack? There are things called packing problems, which are solved with very complicated mathematics. What is the best way to pack a particular box with spheres? Okay. What is the optimum size? What is the given a particular object, what is the maximum, what is the shape it should have so that it has the maximum surface area? Or you could ask the question, given a particular material, what shape should it have so it has the maximum volume? Things of this, questions of these type, which you might think are useless, are actually very useful in life. You know of the company Amazon? Amazon.com?
Yes, ma'am.
Okay. Do you know that all the people behind organizing their websites, organizing their shipping, doing their packing, designing their packing, all this is very scientific. This is all done using mathematics. Also, drug discovery for diseases nowadays is done using mathematics. Okay. How does a plane fly? That is understood using mathematics. One of my maths professors, he's no more, but he, using mathematics, he was not an engineer, using mathematics, he showed how the wings of a plane should be redesigned to save fuel by making it more aerodynamic. Okay. Buildings are put up using mathematics. So the list is infinite. I hope I've answered, helped to make you think about this. All right, there are two more people with hands up. If there's time, I'm happy to take the question. One is Nihal ready?
Nihal, go ahead.
Ma'am, why only ships have buoyancy force? Why can't other materials?
Say that again.
Ma'am, why only ships have buoyancy force? Why can't other materials?
For ships?
Yes.
Why is iron used? I didn't understand your question. So I'm repeating. Did you ask why is iron used for ships?
No, ma'am. Why
Then?
ships have buoyancy force?
I'm sorry, still didn't understand. Bharat, can you help me out?
Yeah, I think he's asking why ships and boats have buoyancy force.
Why they have what?
Buoyancy force.
Didn't understand that word.
It's buoyancy. Buoyancy.
Are you talking about? I don't understand the word.
Let me spell it out, ma'am. It's Buoyancy.
Oh, buoyance.
He is referring to
Yeah,
force.
yeah. You're talking about the lift. You're talking about this is the same thing as the lift. Okay, why do they have? What you're actually asking me is the question of why do they float? It's the same thing. And that we just discussed. Are you happy with that answer?
Yeah, I think he got it. Is
Okay.
there anyone?
Yes,
Anyone
ma'am.
else?
Okay. All right. There's something more. Yeah, buoyancy. Thank you. Yeah. Okay. All right. Anyone else? So are we done?
I think, yeah.
Okay. I think I've taken more time than allotted. I hope this doesn't disrupt your schedule.
No, not at all. Not at all.
Okay.
Thank you so much, ma'am, for giving your time.
My pleasure. Anytime.
Yeah, sure thing. Vikas, one last question, ma'am. We go through many formulas. How can we remember the formulas?
I think you don't have to remember formulas. You have to understand them. Give me an example. Give me an example of formulas that you must never memorize anything in your life. So this is what I tell my students. This is what I tell the kids who come here. So by the way, I'm sitting in the office of Lyra Trust because we have high-speed internet here compared to my place. And let me show you around. It's a tiny little room. And a lot of kids come here, they do puzzles, they're all from the slum next door. And they all memorize. They all memorize. They love to memorize. Well, I don't know if they love to memorize, but I think they hate to memorize. But somehow they seem to understand that it's important to memorize. This is what I tell them. I tell them memorizing causes brain damage. Some things you have to remember, but that happens naturally when you use it enough, or when you read it enough times, or when you think about it enough. But if you have to memorize formulas for everything, there is a problem. So you shouldn't be memorizing. You should be understanding them, even for things like volumes and things like that. Derive it first. If you understand where it comes from, and if you understand how it relates to something else then you'll never forget. I've never memorized anything in my life. And the reason I studied math is because I didn't have to memorize. I was lazy. That's really why. Okay.
Yeah, thank you so much, ma'am. I really wish we would have this session in person. Uh, no, thank you for
Well,
your insights. Thank you for your insights. Though you made the session so simple, I believe it definitely gave some insight to teachers as well as students on how to learn, how to teach, mathematics or for the sake any other sciences.
yeah,
Or
I think the best way is using examples
yeah,
always.
always
Yeah.
use an example, and you also made it very clear that what it means to be curious and how important it is to be curious. uh, Thank you so much for your insights, ma'am.
And everyone do their homework
Yeah,
that I gave.
I've received one homework already. I'll share it to you when you have asked
Okay.
about one about Venn diagram that one student already sent to me, and I'll post it to you in LinkedIn as soon as I get
Okay.
access. Yeah.
Okay. All
Thank you so
right.
much, ma'am. Have a good day.
All right. Thank you again and have a good day, everyone. Bye-bye.